Class 8 Science. We will start new chapter 14, Chemical Effects of Electric Current, and in this video we will discuss about do liquids conduct electricity. First of all, we will revise whatever we have discussed in the lower classes. Materials which allow electric current to pass through them are good conductors of electricity. Materials which do not allow electric current to pass through them easily are poor conductors of electricity. With the help of tester, we can decide that a given material is good conductor or poor conductor of electricity. And about this tester, we have discussed in the lower class. See, this is cell, this is bulb, and these are connected with these wires. Okay. And these free ends of this one and this one, when attached to any substance which conducts the electricity, then you will see that bulb glows. Okay, so we can say this is good conductor. But when these ends of this circuit is joined to this plastic part of that screwdriver, then you will see that this bulb is not glowing. It means this is poor conductor. Okay. Metals such as copper and aluminium conduct electricity, whereas materials such as rubber, plastic and wood do not conduct electricity. Now, whether tester is working or not, how can we verify? Okay, let us see one activity. Join the free ends of the tester together for a moment. This completes the circuit of the tester and the bulb should glow. However, if the bulb does not glow, it means that the tester is not working. Now, what may be the possible reasons? Connections may be loose, or the bulb is fused, or cells are used up. Check that all the connections are tight. If they are, then replace the bulb with another bulb. Now test if the tester is working or not. If it is still not working, then replace the cells with the fresh cells and now check. You will see that tester is working. Okay. Now so far we have discussed that conductivity of the solids. Now we will discuss about do liquids conduct electricity. Okay. Let us see one activity. Collect a few small plastic or rubber caps of discarded bottles. यानी कि जो वेस्ट बोटल्स है उनके कैप ढक्कन को आप कलेक्ट करिए and clean them. Pour 1 teaspoon of lemon juice or vinegar in one cap. I think you are familiar with this vinegar, which is used to preserve the pickles. Okay. Now bring the tester over this cap and the ends of the tester dip into lemon juice or vinegar. Take care that the ends are not more than 1 centimeter apart, but at the same time do not touch each other. Then observe. You will see that bulb of the tester glows. This is the circuit diagram for this. Now in this case we are not using the cell. Now we are using the battery. Now what is the difference between cell and battery? When cells are connected in a series, then we will get the battery. Okay, like this. This represents the one cell. This larger line is a positive terminal of the cell and smaller line is the negative terminal of the cell. This represent one cell. These two lines represent the another cell. So we are using the battery, and this is bulb, and this is a container in which lemon juice is there. You will observe that this bulb glows. So we can conclude lemon juice or vinegar conduct electricity, so they are good conductors of electricity. When the liquid between the two ends of the tester allows the electric current to pass, the circuit of the tester becomes complete. The current flows in the circuit and the bulb glows. When the liquid does not allow the electric current to pass, the circuit of the tester is not complete and the bulb does not glow. But in some situations, even though the liquid is conducting, we know that is liquid is a conductor, but bulb may not glow. Now why? What may be the reason? As we know, why this bulb is glowing? Due to the heating effect of current. When we pass the current, then heat is generated. Okay, and this heat, due to this heat, the filament of the bulb gets heated to a high temperature and it starts glowing. However, if the current through a circuit is very weak, the filament does not get heated sufficiently and does not glow. Clear? So we can say whatever the material we are using, that gives the very weak current. Okay, that's why sufficient heat is not available and filament of that bulb will not heated and it will not glow. So in such cases, we use LED to detect weak current. Now what is this LED? LED means light emitting diode. Okay, these are the LEDs. There are two wires. These are called leads attached to an LED. See, this is the one and this is the another. One lead is slightly longer than the other. While connecting to a circuit, the longer lead is always connected to the positive terminal of the battery and the shorter lead is connected to the negative terminal of the battery. LED glows even when a weak electric current flows through it. Okay. Now there is another way, or we can also make the one another tester which can detect a weak current. Okay. And we can use magnetic effect of an electric current to make another kind of tester. Now again, this magnetic effect of electric current we have discussed in the lower class. Okay. Electric current produces a magnetic effect. Compass needle. You are familiar with this? This one is compass needle. Okay. Kept nearby when current flows in wire shows deflection. Even if the current is small, the deflection of the magnetic needle can be seen. And I think you are familiar with this activity in the 7th standard we have discussed. Okay. This is a compass needle kept in an empty matchbox. Okay, and when circuit is completed, then this is in on situation. You will see the deflection in this. Okay, so we can conclude that when electric current is passed, it produces a magnetic effect, and due to this magnetic effect, there is a deflection in this needle. Now we can make the another tester using this effect. See the one activity. Take the tray from inside a discarded matchbox. Wrap an electric wire a few times around the tray. Place a small compass needle inside it like this. Okay. Now connect one free end of the wire to the terminal of a battery. This one end is connected to this terminal of the battery. Leave the other end free. This end is free. Take another piece of wire and connect it to the other terminal of the battery. Now we'll take this is the another piece. This is connected with this another part or another terminal of the battery, and it's again this another end is free. Now we will get these two free ends of the circuit. Join the free ends of two wires momentarily. Momentarily क्षण भर के लिए, बहुत कम समय के लिए इनको आप join करिए. Then you will observe that compass needle should show deflection. Here, if this deflection is not observing, that it means there is some mistake in this circuit. First, we will correct that mistake. The tester with the two free ends of the wire is ready. Now take lemon juice in a beaker or in a cap of discarded bottle and dip the free ends of the tester in it. There is a deflection in the compass needle. Take out the ends of the tester from the lemon juice. Dip them in water and then wipe them dry. First of all, we have tested for this lemon juice. Now, if we want to test for the another liquid, then we have to wash these two ends with the water and then we have to wipe them dry. Then repeat the activity with other liquids such as tap water, vegetable oil, milk, honey. And on that basis, on the basis of observation, on the basis of deflection in this compass needle, we can classify the liquids as good or poor conductors of electricity. Let us see this one. Lemon juice. Compass needle show deflection? Yes, good conductor. Vinegar, deflection is yes, good conductor. Tap water, deflection, show deflection, yes, good conductor. Vegetable oil, no deflection, poor conductor. Milk, deflection is there, good conductor. Honey, no deflection, poor conductor. Soda water, simply we can say soda. This deflection is yes, good conductor. Kerosene oil, no deflection, poor conductor. Okay. Now, conduction of electricity through distilled water. One, take the activity. Take about 2 teaspoonfuls of distilled water, and this distilled water is available in the chemistry lab of our school, or this is also available to the medical shop. Okay. In a clean and dry plastic or rubber cap of a bottle. Use the tester to test whether distilled water conducts electricity or not. We'll see that bulb of the tester does not glow if free ends of the tester is dipped in the distilled water. Okay, then we can conclude that distilled water does not conduct electricity. Okay, now dissolve a pinch of common salt in a distilled water. Now again taste with the help of tester. We will see that bulb glows. It means when salt is dissolved in distilled water, we obtain salt solution, and this is a conductor of electricity. Clear? The water that we get from sources such as taps, hand pumps, wells and ponds is not pure. It may contain several salts dissolved in it. Small amounts of mineral salts are naturally present in it. Thus, this water is thus a good conductor of electricity. On the other hand, distilled water is free of salts and is a poor conductor. Now, we can define what is distilled water. The water which is free from any type of dissolved salt. It is called distilled water. And when it does not contain any salt, it is a poor conductor of electricity. Most liquids that conduct electricity are solutions of acids, bases and salts. Small amounts of mineral salts present naturally in water are beneficial for human health. However, these salts make water a good conductor, so we should never handle electrical appliances with wet hands. गीले हाथों के साथ में electrical appliances को handle नहीं करना है. Because this water, whatever the water we are having at home, this is a good conductor because it contains the dissolved salt. Or while standing on a wet floor, गीले फर्श पे भी खड़े हैं तब भी आपको electrical devices को handle नहीं करना है. Okay, thank you. Subscribe my channel to get the next video from this chapter.